Human ears are dumb. In relation to barn owl ears, I love barn owls because barn owl ears, in addition to them being silent, deadly predators, they can fly through the air acoustically silent, like they're creating no pressure waves with the way that their feathers have evolved. They create almost no sound while flying. They're flying silent death machines, which is cool in and of itself. But humans, they have ears that are level with each other like this. So we are good at detecting where, like just general direction of where a sound is. If something is louder over here, then we should be able to tell, oh, it's not as loud over here. So the sound's probably somewhere over in that direction. What barn owls have are ears that are not only like this, but slightly offset. And because they're offset, not only can they tell the direction left to right, they can tell up and down. So they can directionally focus in and locate a sound with their asymmetrically placed ears. That's how they can get at tiny mice, even if they're 2 feet underneath the snow in the dead of winter. Also, they scream like banshees. That's where we think the banshee legend came from. Go ahead and watch it. Look up barn owl screech on YouTube. Turn the volume down. Hello and welcome to another edition of Because Science Footnotes, the show where we look back and reflect on the previous bunch of nerdery that we got up to, and we take your comments and your questions and your corrections and address them here head on to see what else we can learn and what else we can get interested in, like barn owl ears. So, on the last episode of Because Science, I talked about your actual chances of making it through Harry Potter's famous platform 9 3/4. I was jumping off from a Twitter thread by Sophia Nasser, who is a PhD cosmology student at UC Irvine. She calculated the chances of a human-sized particle phasing and quantum tunneling through a wall. I used her lead and applied that to Harry Potter, and I said that there is a non-zero chance. I'm saying there's a chance. But the chance is so vanishingly small that I literally could not show you in full. Because to write out that many digits, I would die first of exhaustion. But what did you have to say? Before we start getting into the comments, I have to address a very special comment, an entire video that Shad Diversity posted on his YouTube channel, all commenting about my recent super strength video. As I said, you don't want it. He agreed with me and added a lot of other really interesting points. And I actually, thank you so much, Shad, I actually watched your video about sword strength in preparation for a very special episode of Because Science that's coming up in a non-specific amount of time. And that's why your video about my video popped up, and now we have a videoception going. And like the movie, it's getting harder and harder to follow. But thank you so much for the shout out. That was very nice. Everyone go watch his video if you want to know more about the ins and outs of super strength. So our first comment comes from Oscar Bogenberger Damsel, another good comment, in which he says, just wondering, does the speed you go affect the chances of passing through or quantum tunneling through a barrier or a wall? Would it be more likely to work if you went at light speed? Yes. In the equation, the quantum tunneling equation that I showed in the episode, velocity does matter, and therefore your chances would go up if you approached Harry Potter's platform 9 3/4 at a higher velocity. But for a particle like us, a human-sized thing, is difficult because as we, something with mass, approaches the speed of light, we acquire what's called relativistic mass, and we get more and more massive, according to the equations that smart boy Einstein figured out. So as we get more mass, our chances to quantum tunnel accordingly go down. So we may be going faster, but we're also getting heavier, so there's not really a better way around this. But I like where your head's at, looking at the equation and seeing what the variables do. That's smart, but then you have to consider all the other stuff. That's what smart boys do. Our next comment comes from Strangely Amusing, who says, we also experience quantum tunneling in our own bodies in the form of proton tunneling. It's one of the mechanisms for genetic mutation, if I'm remembering correctly. I think Strangely Amusing is commenting on something very specific here, so I'm not going to comment on it. I will say that as the years and the decades have gone by, we have realized, or scientists have realized rather, that the world is in fact underpinned by quantum mechanics. We knew this. At the smallest scales of the universe, quantum mechanics dominates. But what I mean is, in biology, it seems like quantum mechanics has some noticeable effect, even for things that are so big, such as we. So for example, there are studies looking into how quantum tunneling in chemical reactions inside the cells of our body allows those chemical reactions to happen even more quickly for enzymes. There's also research into how birds and other animals that migrate long distances use quantum mechanics to lock in and home in on the Earth's magnetic fields, more specifically quantum entanglement for some of these birds. So life can use quantum mechanics, and you can see some of its effects if you look in the right places. A good place to look is magnets. When you're seeing magnetic effects, even just like with a simple bar magnet, this is a macro scale quantum mechanical effect. And if you want an even cooler example of that, check out quantum levitation. The whole world, it's magic all around, except it's magic that makes sense. Ding. Next comment comes from a number of people who all say that I'm probably a Ravenclaw. What do you think I am?
Slytherin?
Exactly. Everyone who knows me knows that I'm a Slytherin through and through. I mean, Ravenclaw is kind of the simple answer if you ask me. It's like, oh, smart stuff, right? No. I'm obsessed with power. And they had Merlin. Yeah. And I had a pet snake when I was a kid. His name was Vinny. He was a vine snake and he escaped. I do not know where he is. He got in the fence once. That was scary. Oh no. He was small. He couldn't have strangled me. Why am I thinking about this? He's dead. I was the kid during show and tell. I brought the snake into school. I put it in a little basket with mulch and I brought the snake in and people looked at it.
Classic Slytherin.
Aaron, why don't you understand my came to snake? I'm a snaky boy.
Okay. Our next comment comes from Javi Kuri, who says, hey, I want to ask you a question. I want to become a scientist when I grow up, but I don't know what type of science I should study, so my question is, what type of scientist does the world need most right now? Well, Javi, I do not have enough experience to say what the best field to get into right now, or even if it's the right question to ask if there's a best field. What I will say from my experience is that you should go with what you're really passionate about. Your chances of making a real difference in the world, Javi, are much better than e to the 10 to the 35 if you are pursuing something that you are genuinely curious and interested in. That's what I did. I went into engineering because I wanted to help change the world. I went into environmental engineering specifically because I knew that climate change would be a huge issue by the time I got out of school. But while I was in school, I decided to pursue something that I was really passionate about, which was talking about science and trying to explain it and getting other people interested in it. So that's what I did. And I think I'm happier than I would if I was just behind a desk doing calculations, which is where I think I might have ended up. So follow your passion. And if that passion is science, let the field speak to you. They could use you. Next comment comes from Chinook, who says, I guess no, it's not possible to shuffle a deck of cards in the same order, but then again, false shuffles exist for good reason in that case, since it makes the improbable seem magical. I really like what Chinook is getting at. Basically, the odds of shuffling a normal deck of playing cards, if you shuffle it thoroughly, then you'll have a completely randomized deck of cards. And the chances of doing that twice and getting the same order is in the order of 10 to the 67. 1 in 10 to the 67. Incredibly low. So if you do it right, the odds that anyone has ever shuffled a deck of cards into the same order that someone else has is almost 0 on the timescale of human playing card existence. What Chinook means, I think, is that because it is so improbable, magicians have to use sleight of hand and false shuffles to get around this improbability. Otherwise, it would be some kind of magical if the magician shuffled your card into the deck of cards randomly and it was in a certain order. They have to get around that with magic. But even in that case, magic is fooling you. And our super nerd comment of the week goes to Apache Thunder, Private Eye. I don't know what you do for a living. Who says a lot. But what he gets at is thinking harder about what possibly phasing or quantum tunneling through objects would mean in everyday life. So if it was highly likely that you could quantum tunnel through barriers, then it would be a total hassle. You wouldn't just go through walls, you would also, I don't know, partially sink into the floor on occasion. I might quantum tunnel through this desk chair and fall on my butt randomly. Like this. Totally annoying. If something like that happened to you all the time, it would be totally irritating. Apache points out, what if you were on the toilet and suddenly you are quantum tunneled into the water? It'd be a total hassle. But what Apache Thunder did is totally overthink our conclusions that we came up with in our little topic. So congratulations, Apache Thunder. You are a super nerd. Nice. But of course, I'm not always right. What were your best corrections for this week's episode? Our first correction comes from Nair Day T, who says, "Good evening, have a question. Hey, you considered the human body to be like a giant single particle. What would happen if we considered the human body as it is, trillions of individual particles? Would the chances go down to quantum tunnel?" Yes, you're absolutely right. For simplicity's sake, I considered the human body to be a single particle so that it was easy. But the human body is not a single particle. It is many, 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 many particles. And because all those particles are kind of doing their own thing quantum mechanically, the chances that they would all quantum tunnel through a barrier at the exact same time, the exact same distance, having the exact same energy, is even lower than what I described. And what I described is I can't write it out. There's not enough space in the universe. So what would have to happen, as Dr. Christopher Baird explains on a blog post that I liked a lot, is that all of our body's particles would have to be moving in sync with each other, somewhat kind of all following the same order, so to speak. They would have to be coherent, all doing the same thing at the same time. Like how all of the light waves in a laser are coherent. They are all doing the same thing. They all have the same wavelength as they go. That's what makes the lasers so intense. So your human body would have to be like a body laser. Cool. Our next correction comes from multiple people who say some variation of, if you go through the wall, would you be on the platform to Hogwarts though? Wouldn't you just phase into the brick wall or through it and you just still be in King's Cross Station and not wherever the magical children's went? I guess in my head, what I was assuming was that if you pass through the single wall, it's kind of like a TARDIS situation where the magical world is on the other side of that and it's bigger, which isn't very scientific, I know. You are right. If you just went into the brick wall, you'd be inside of a brick wall and you'd die, or you'd be on the other side of it, which wouldn't really help. So you would need, like I said, how you would need some magical assistance to quantum tunnel your entire body reliably in the first place. There would have to be some magical portal or teleportation occurring to get you into the location that Harry Potter ends up. But I think what I was saying is still sound, that you have to get through that wall first, if it's not just an illusion, because you can see it also can become solid in the movies. You see that. So yes, you're right. You do not want to end up inside of a wall or inside of a star, as Han Solo would say. That sounds like an episode. Do you want an episode about can you fly through a star with hyperspace? I don't know. Let me know. I might do it. Our next correction comes from, I hope I pronounce this right, I'm sorry if I don't, Matij Sarnik, who says you wrote 0.92 millimeters. The point was actually a multiplication sign, whatever. But shouldn't you use SI or SI units in the equation that you wrote? So in the quantum tunneling equation, the probability equation, I said multiplied by 92 millimeters. What Matij here is saying is that it should be meters for all the units to work out, and yes, you are right. It's a small correction, but I appreciate it. For all of these equations that I use in these episodes, units do matter, and if I'm not showing you how I'm converting those units, and I'm not saying anything about it, then I'm not being as forthcoming as I could about what's going on, and I always try to show you the steps of what I'm doing, so I'm sorry that I did not convert all the units. I also didn't do that for the kilometers per hour value that I also had in that equation. I'm sorry. I switched over to metric. On the show, I started off doing just imperial, but I switched to metric because it's easier, and everyone else does it, except for, the United States and some other country. Sometimes I get it wrong. I blame my education. Our next correction comes from multiple people again who say some variation of, how did you Accio your own wand if your wand wasn't in your hand? I Accio'd my wand with a wand in a free hand that you didn't see. Just like this. Accio marker. See? Wand's down here. Hey, also, I've been informed in the books, the wand is only a tool to focus magic. The magic comes from you, so you can Accio things to you all you want. It's just easier with a wand. So technically, I'm right, the best kind of right. Read a book. Our next correction comes from Jared Biesinger, who says, what's funny is that number, that chance I said, 1 over e to the 10 to the 35, should actually be smaller because not only was it the mass of Harry, it would also have to be the mass of the cart he was pushing through with all of his luggage, wouldn't it? Yeah. Now the chances are not just a human-sized thing, but also all the individual pieces of luggage and the cart and all of his clothes and his glasses. And if any of those went wrong, it's gonna be either bad, inconvenient, or really embarrassing. But good correction, I did not think about including the mass of everything else. Look, the chances are so low that having them be more low, relatively speaking, it's the same order of low. But our best correction of the week comes from Marcel S, who says, by definition, I think that 1 over e to the 10 to the 35 is an irrational number, which is true. And so any irrational number, e is like pi in that sense, any rational number would take more than a lifetime to write down every digit, wouldn't it? You're right, there's also not enough room in the universe, like I said, to write out all the digits of pi. Pi is an irrational number like e, so it was always gonna be too big to write out. True. But what I meant was everything after the decimal point. So even before you get to all of those numbers, like in pi, that repeat forever randomly, you have this gigantic number, e, multiplied by itself, a trillion, billion, uh-oh, lost it, 100, yeah, yeah, that many times. A trillion, billion, 100 times. About 2.7, so you have 1 over this giant number, and then you have all those decimal places. So it would take more than the age of the universe to write out just everything before the decimal point. And then it would take even more afterwards. In fact, it would take forever, literally. Great correction, absolutely right. I didn't even think of it, because I was just considering those large numbies. Congratulations, Marcel, you are indeed a super nerd. Now, if you are already subscribed to Alpha at projectalpha.com, you already know what the next episode of Because Science is going to be because you got it 2 days earlier than everyone else. But if you're not subscribed, the next episode of Because Science is going to be about Space War. Space War. Talking about Space War. That's right, in this week's episode, we're gonna take a look at how science might predict a space war would actually go down. Now, we've covered this topic before, but not quite like this. We consider what ships would look like and what weapons they would have. This is how engagements would happen in space. In TV shows and comic books and movies, we see naval-style engagements happening very close together, and they can see each other outside of windows, but using reasonable assumptions and some scientific predictions about what the future of space flight and space combat might be like, how would space war actually look, and how would that differ from pop culture? Spoiler alert, it differs. but you'll have to watch the next episode for that. So go watch the latest episode of Because Science about Harry Potter's Platform 9 3/4 if you haven't yet, and leave me your comments, questions, and corrections at youtube.com/becausescience, facebook.com/becausescience, and at Because Science on Instagram and Twitter. I pull all of this stuff for this show from there in the first few hours after I post the new video because I have to film this show. So get there quick and leave your nerdiest comment, and hopefully I will see it. And don't forget, you do not know when you're contagious. We have an intuitive sense as people, as humans evolved on this planet. We have intuitive knowledge of things. There's an intuitive physics. I know from when I'm born to when I'm a little bit older that if I threw this pen, it's gonna go in kind of an arc. I know that intuitively. We seem to have the same kind of intuitive sense about health. We seem to have an idea of like, oh, I know when I'm sick, I know when I'm contagious, and I know when I can come into the office or not, Karen. But our intuitive sense of our own health is wrong most of the time. Unless you know exactly what kind of illness you have no idea what period you are in contagiousness or just being sick or the beginning or the end of it, and you are likely to get the rest of the office sick. Go home. Take care of yourself. I saw a study where cold germs could spread through an entire office via the surfaces of that office in 2 hours if one person was sick. Take care of yourself. I gotta go talk to Karen just a second. Oh, bye.